Hey, what's up, guys? This is Mr. Hart, and I decided to make a little video for you all to kind of go over volume, kind of like what I would do in the classroom on the very first day, introducing it. Now, I'm going to go a little bit quicker than what I would normally do, just because it's just me talking, and I'm going to try not to make this last forever so it's not too boring for you. But I'm just going to kind of go over the basics, and hopefully, this is easier for you to understand and follow rather than the video that I posted or the slides that there were, because I know that can be a little bit confusing. Also, for those of you that have been trying it and working on it, I want to thank you, because again, I know this can be kind of difficult, especially to understand without me there, without you being able to ask questions in person. So hopefully this clears things up, and then just like you all have been doing, if you have any questions about anything at all, how to do something, anything, just either write a comment on Google Classroom or you can just send me an email, whatever's easier. So let's go through this here. First of all, whenever we talk about the volume, we're talking about the amount of space inside a three-dimensional figure. So if you think about like a vase, like what you put flowers in, we're talking about how much water would it take to fill it up completely. Now, we're going to be talking about cylinders, cones, and spheres. So whenever we talk about the volume of one of those, we're talking about how much space is there on the inside. How much would you need to fill it up? So there's three things that we're going to be looking at for these formulas. The first one is pi, and for pi, we're going to use 3.14. Now, if we were in class, I would show you where the pi signal is on the calculator, and if we were all using the exact same calculator, it would be a little bit easier, but because of the situation we're in and people will be using different things, whether it's a calculator on the computer or your phone, anytime you see pi, we're going to do 3.14. Then h is going to be your height. That's how tall something is. And then r is the radius. That is half of the distance across the circle. Okay? Now, sometimes they're going to give you the diameter, which is the entire distance across the circle. We do not want the diameter. We only want the radius. So, if your line goes from the middle to the edge, we're good. We're going to use that number. But if your line goes from side to side, we're going to divide that by 2 because we only want half of it. So, if it looks like this, we're good. That's what we want. That's the radius. If it goes side to side, you're going to divide that by 2, and that will give you your answer. Okay? So, let's get into some examples here. Our first one is a cylinder. Whenever you think of a cylinder, think about like a Coke can, or kind of those large trash cans that you might see outside of school. So, the formula is, the volume is pi times radius squared times height. Remember, whenever you have variables and symbols all right next to each other, if there's nothing separating them, we're just multiplying. So whenever we multiply something, we should know by now that you want to use parentheses to kind of separate everything. So what we're going to put in the calculator is 3.14 times radius squared. Now remember, when you square something, that means you multiply it by itself. So radius squared means radius times radius, and then times the height. So let's get into an example here. Number 1. 5 is our height, because that's how tall it is. And then 2 is our radius, because that is half of the circle. So 2 is our radius, 5 is our height. So what we're going to put in the calculator is we're going to say the volume equals, instead of pi, remember we want to use 3.14 times radius squared, which is radius times radius. So since radius is 2, 2 times 2, and then times our height, which is 5. I am going to show you how to do this on an iPhone calculator, because I know a lot of us have that. But if you're using a computer calculator or a different phone calculator or whatever, these are the basic operations, so this will work on anything. So we want to do 3.14, or actually let me go back a step. Instead of multiplying all this out together, let's go ahead and say what 2 times 2 is. That way we're not typing as many things in the calculator. So 2 times 2 is 4. So now let's put this in the calculator. My fault on that, but I think this will be a little bit easier going forward. So 3.14 times 4, which was 2 times 2, then times 5. So my volume is equal to 62.8. Then we want to put centimeters down, and then we're cubing it because we're talking about the volume of a three-dimensional figure. Now, this part here does not really matter that much for this week with everything going on, because whether you're doing it in IXL or whether you're doing it on the quiz, you're not going to have to write your units of measurement. But we're going to go ahead and go through it, or I'm going to show you what to do just like we would in class, just so you know for next year, so you're aware, or whenever you might be able to use this stuff again. So then we're going to do the same thing for this one. So my height is 7. That's pretty easy to pick out. Then you want the radius. So again, remember, your radius is half of the circle. That's what we want. If your line goes side to side, we want to cut it in half and just use half of it. So because this is side to side, 6 all the way across, we only want half of it. So 6 divided by 2 is equal to 3. So 3 is actually going to be our radius, and that's what we're going to use. So for pi, we're going to do 3.14. Then radius squared is radius times radius. I thought about that wobbling. So we're going to do 3 times 3, and then times our height, which is 7. Again, it's probably easier just to go ahead and say what 3 times 3 is. That way we're not typing as much into the calculator and we don't have as much room for mistakes. So 3 times 3 is 9. So that is what we want to put in the calculator right there. So 3.14 times 9 times 7 equals 197.82, and then we're dealing with inches cubed. Okay? So again, both of those were done the exact same. The only difference it was this one we wanted to use 2 because it was only half the circle already, which is the radius. This one they gave us the diameter, so we had to divide it by 2 to use that. Okay? We've got 2 more examples for us here. So here is the cone formula. The cone is very similar to the cylinder. The only difference is that a cone is 1/3 of the size of a cylinder. So most of the formula is the exact same, pi radius squared times height, but you're going to multiply it by 1/3. Remember, multiplying by 1/3 is the exact same thing as dividing by 3. So we're going to make this really simple. We're going to type in the exact same thing we did for a cylinder, except at the very end, we're going to divide whatever our answer is by 3. Okay? So we'll go through these a little bit quicker because hopefully we got used to it on the cylinder. So your radius is 2 because it's only half of the circle. We're good. That's exactly what we want. And then your height is going to be 7 because that's how tall the cone is. So what we're going to put in the calculator is we're going to kind of use this as our formula, okay? And we got this from this, but to me this is easier to put in. So pi, which is 3.14, times radius squared, which is radius times radius. So my radius is 2. So that means 2 times 2. And then times my height, which is 7. And then whatever we get for all that, we're going to divide by 3. Okay? So what we're eventually going to put in is 3.14 times 2 times 2, which is 4, times 7, which is our height, and then we'll divide it all by 3 to get our answer. So let's type this in here. Whoops, sorry about that. And see what we got. So 3.14 times 4 times 7 equals, divided by 3, and this is our answer, 29.3. Now, every time we round something this week, we're going to round it using 2 numbers after the decimal point, so to the nearest hundredth. So we keep the 3, then my second number is 0. So that's where I want to stop. But remember, you want to look at your third number. If it's 5 or higher, then you round your second number up 1. So because 6 is greater than 4, because it's 5 or more, we're going to change that 0 to a 1. So we're going to put 1, and then we're dealing with feet cubed. Again, the units of measurement, we're not that worried about. All you really need to do is get to this number. Okay, but I'm going to write this down for us anyway. All right, let's do another one here. So here's my other example of a cone. 9 is my height because that's how tall the cone is. Even though it's kind of slanted a little bit, I can still tell that that would be the height if I was setting it up right. So 9 is my height. Then I need to know what my radius is. Remember, the radius is only half of the circle. So over here, we were able to use 2 because our line was only from the middle to the edge. But here we go edge to edge. So I don't want the entire thing, that's the diameter. I just want the radius. So if from side to side it is 8, that means half of it is 4. So that means my radius is going to be 4. Okay? Then we're just going to do the exact same thing we did on the last one. So what we're going to put in is 3.14 pi times radius squared, which is radius times radius, which is 4 times 4, then times our height, which is 9. Whatever we get for all that, we're going to divide by 3. So volume equals 3.14 times 4 times 4, 4 squared, which we should know is 16, times 9 divided by 3. So let's put all this in the calculator here, and let's see what we get. So 3.14 times 16 times 9 equals divided by 3. And we get an answer of 150.72. We're in feet again, so feet cubed. Okay? So there are 2 examples of a cone. Alright, our last shape is a sphere. What a sphere is basically a ball. Think of a bouncy ball, basketball, soccer ball, whatever you want. Okay? Now, our formula for this one is a little bit different. It's 4 over 3, so we'd say 4/3 times pi times radius cubed. So if radius squared means radius times itself 2 times, radius cubed is going to be radius times radius times radius. Now, since we're multiplying that by 4 over 3, again, if we were in school, I would show you how to put that in the calculator really clean and put it in as a fraction. But because some of us are using phones as calculators or different things, I'm going to try to make this as simple as possible. So what we're going to do, we're going to keep the 4, the number on top, our numerator. We're going to keep that in the numerator of the fraction. And then this 3 on the bottom in the denominator, we're going to do kind of like what we did with the cone. Whatever we get for this answer, we're just going to divide by 3. So you can think about this formula looking like this. 4 times pi times r cubed divided by 3. Okay? It's the exact same thing. So, let's get into it here. On number 5 here, our first sphere problem, this line goes side to side. So, hopefully we're kind of recognizing now that we do not want to use that. That's the diameter. So, we're going to cut it in half, and we're going to use 3 as our radius. So, 3 is actually what we're going to put in. So, when we put our problem in the calculator, we're going to do 4, because we're going to keep that on top for our fraction, keep that as the numerator, then times pi, which we're going to do 3.14, then times radius cubed, which is radius times radius times radius. So we're going to do 3 times 3 times 3. Then, whatever we get for all that, we are going to divide that by 3. So, we're going to do 4 times 3.14 times 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. if you'd like to, I would recommend you typing that in just to make sure. So 3 times 3 times 3 equals 27. And then whatever we get, divided by 3. So let's put this in here. 4 times 3.14 times 27. Then we got to make sure that we divide it by 3. So divided by 3 equals 113.04, or in inches cubed. Okay? Last one. So here's another sphere. Because my line starts in the middle and goes to the edge, then that's good. So that's what I'm going to use as my radius. I'm going to use 7. I do not have to divide that one by 2 because the line's only halfway anyways. Okay? So over here it went side to side. That's why we cut it in half. But here it's already basically cut in half. So it's good to go. We're just going to use that how it is. So what we're going to put in the calculator is 4 times 3.14 times radius cubed. So cubed means times itself 3 times. So we're doing 7 times 7 times 7. Then whatever we get for that, we're going to divide our answer by 3. So just so we're not typing as much in the calculator, let's go ahead and see what 7 times 7 times 7 is. So 7 times 7 is 49. And then 49 times 7, I'm not going to act like I know what that is off the top of my head. So 7 times 7 times 7 equals 343. And then we'll divide all that by 3. So let's type this in here. 4 times 3.14 times 343 equals, we got a really big number there, but when we divide it by 3, it gets a little bit smaller. So we're going to do 1,436.0. Now, I want to stop at this 2 because we want to stop after the second number after the decimal. But because my number after that, because my third number is 5 or higher, so since it's 6, I'm going to round that 2 up to a 3. Then we're dealing with centimeters. So we write centimeters cubed. And that is our answer. So, once again, hopefully this helps you all out. If you have any questions, email me, write a comment on Google Classroom. I would recommend pausing this video as much as possible, going back and looking at it. Watch this video as you do the practice problems on the slides or as you're doing an IXL video, and that should help you out. So, good luck everybody, and again, most of the grades for this week are just going to be, in fact, it's only participation. But just because it's just participation doesn't mean just click answers and hit submit. You need to try it. I want you to try it. If you have a couple weeks in a row where it's all zeros or all just 1 out of 6, 1 out of 9, then I'm going to start looking a little bit closer at some of the work that you're turning in to make sure you're trying. So, good luck, and if you have questions, let me know. See you guys.